Hello everyone. Today we are with Radoslav Gatev and we will talk about Dapr or Distributed Application Runtime. Actually, Radu Gatev is one of the first people who wrote book for this framework. So welcome Radu, and I'm really very happy that you are here and you can share something about the framework and about the book.
So, hi everyone. Thank you, Mishu, for having me, and thanks for the invitation to do this webcast. So, first of all, I'm Radoslav. For those who don't know me, I identify myself as a technical architect or cloud solution architect, depending on where you see me, because I don't have a formal title because I stay independent, and I actually set my titles depending on what projects I am. But basically, I come from a very strong programming experience, mostly related around Microsoft .NET framework, and I also have some passion for data. And I've been involved in a couple of projects with a lot of data. So that's pretty much it for me. So maybe now is the time to discuss a little bit around how I end up writing a book.
Exactly.
Um, so although we are Microsoft MVPs, for some reason I didn't see Dapr coming. We have some access to NDA content, to private information around across Microsoft, but I didn't see Dapr coming, and I heard about it for the first time during Microsoft Ignite back in 2019. I think it was in October, and Mark Rusinovich, the CTO of Microsoft Azure, delivered a very interesting session to me with some new thing called Dapr, which stands for Distribution Application Runtime. And at that time, I found it very interesting because it did ring some bells about design patterns, as Dapr delivers some reusable functionality that you can use in your distributed applications. And I decided to give it a try to learn more about it. At that time, Dapr was 0.2, I think, and now it's 0.3 is the latest release. So at that time, Dapr was an unstable project. It didn't have too much documentation where you could learn from. So I have to reverse engineer some things in order to get used to it. And March 2020, they canceled our MVP summit. I was in between projects. Actually, all of those opportunities that I had around March 2020, I lost them. So basically, it couldn't get any worse than that. So I decided to write an article about Dapr, which ended up being very viral. I mean, a lot of reshares, a lot of retweets, and things like that. And somehow, these guys from Apress, which are very well-known publisher for technical books, reached out to me, and we had a brief call, and I ended up proposing to write a book about Dapr because that was the thing that excited me around that time. And here we are, almost a year and a half later, and the book is published. And I learned a lot of things about myself, a lot of things about the technology itself, and I learned that writing a technical book about a technology that is currently under development is a very difficult thing to do because after I have spent 1 year in writing this book, the first draft was done. Then I had to um, basically change some parts of it because Around March 2021, Dapr reached production ready phase with its version 1.0, and I had to rework some parts of the book actually.
Actually, it is very interesting for many people who are considering to write books and other technical content. What kind of challenges you met during the whole this process when you wrote this book?
Well, I think the most difficult thing was to try and oversimplify some of the concepts in order to make them more understandable by the beginners, and basically gradually introduce new concepts and new things. So I guess that the the flow that I followed during the writing process was maybe most of the most difficult thing that I had. And the other thing was related to the technology itself, because as I said, it was in preview until a couple of months ago, and a lot of the things were undocumented, and I had to basically be a part of the Dapr members and to be a part of community, and to work with the Dapr code. And by the way, Dapr is developed out in the open, so it's available in GitHub. You can find all its source code within GitHub, within a couple of repositories actually. And I think those were the top two most difficult things that I faced.
Yes, it is very interesting, but probably because we have relatively short session, it will be great to explain what exactly is Dapr and why we need to use it.
Okay, so I doubt that there is a person who can explain Dapr in just one sentence, because Dapr is a lot of things. But let me try. I mean, Dapr provides some useful patterns. It's obviously a runtime. It features code reuse, and it provides you with a couple of building blocks. Building blocks are the packages of functionality within Dapr that allow you to do different things. And Dapr is language. Dapr is language agnostic. Dapr is framework agnostic, and also cloud and vendor agnostic. So you are not locked into some technology or framework that you have to continue using um, over and over again. So basically, you can use Dapr as soon as you have basically the HTTP stack implemented within your framework where you execute your code. Because Dapr features the sidecar architecture. This is, by the way, commonly used within the microservices world, where you have some sidecar container or sidecar process, which acts like a companion to your applications, and it basically runs side by side your applications and provides some useful functionality to your basically application code. And with that, you can reuse some functionality without changing your existing code. I'm talking about the generic sidecar pattern. And Dapr is injected just in this case, like this. I mean, it's a sidecar process or a sidecar process as a sidecar container. Sorry. It depends on where you host your application actually, because you can be within Kubernetes or you can be within a self-hosted mode, basically where you settle yourself the virtual machines and the infrastructure. And in this case, Dapr is just a process running side
Do,
by side your application.
do you think that we can also discuss about main use cases and business cases where we can use Dapr? Because we started to talk a little bit more about building blocks, but for our attendees, especially for those who have no experience with Dapr, probably is very useful to know what exactly they will take as benefit if consider to use Dapr.
Okay. Well, maybe it makes sense to briefly describe the building blocks, but I will leave that for one minute after we speak about that. But basically, Dapr allows you to reuse some common functionality. Like, so let's describe the flow when you want to use some kind of external system, like for example Redis or for example Kafka. If you are coming from the .NET framework, or actually it doesn't depend on the language that you are going to use. For sure, you will look for some kind of a library that you can use, which is widely accepted by the community. It has a lot of contributions, and it behaves it behaves well for your and stable for your applications. So you will choose one library for, let's say, interfacing with Redis in .NET, but you may have a Java application somewhere. You may have a Python application somewhere. And within all those ecosystems, you have to identify the respective library from it, for example, that you can use in order to interface with the same external system. And how can you achieve code reuse without providing something very generic, something that executes under different languages or different platforms, which is um, not really feasible at all? How can you achieve things like that? Well, you can achieve them at the protocol level. You can provide this functionality at the HTTP level or the gRPC level, where basically your Dapr sidecar runs, and it waits for requests from your applications, and it can trigger requests back to your application, depending on the building block you use, by the way. So it really takes out this requirement for you to step out in your project and identify what type of library to use in order to interface with some external system. Another thing will be that Dapr provides service discovery. You know that in the distributed world, where you have multiple microservices running in a cluster, you need to have some way for identifying where your applications are running and at what addresses. So Dapr also handles this by providing a pluggable service discovery components. So basically, you can plug different components depending on where you are hosting your code. Let's say if you're inside Kubernetes, you can use the built-in services of Kubernetes and you will basically point to your applications by just typing the service FQDN, and Dapr will know that, and it will handle this behind the scenes for you, actually, by silently reusing the services functionality within Kubernetes. But the whole point of this is that the name resolution component is pluggable. And let's say if you are running in some legacy mode where you are hosting virtual machines or virtual machine skill sets, and you have some Python applications, you have some .NET applications. Some of them are running within Windows, some of them are running on Linux, some of them are containerized, some of them are not. In such cases, you have to choose some hybrid approach for doing the name resolution. And recently, they released a component, name resolution component within Dapr for using Consul as a DNS service. So Consul is yet another service mesh, and it provides very useful functionality when it comes to being able to discover services within environments that host different kinds of platforms like Kubernetes, virtual machines, containers, and things like that.
Great.
So it's not a homogeneous environment.
Yeah, thank you very much. So probably we can go ahead with building blocks and everything which you can share about this platform.
Okay. Can you hear me now?
Yes.
Okay. So the weird hardware flip switch of my headset basically had turned itself on. Anyway, so I briefly touched on the hosting modes of Dapr. You have a self-hosted mode where Dapr runs as a standalone process next to your application process, and within Kubernetes, Dapr runs just as a container next to your application container within the same pod. So when you want to call application A from application B, for example, you have to use the service invocation block. The way for doing so is to call from application B, you have to call your Dapr sidecar companion and basically instruct it to call your application A. And you don't have to care where this application is running, actually, at what address. And Dapr will act as a service, as a proxy in between those two services, and it will feature some out of the box functionality like mutual TOS encryption, which means that basically all the communication between those two services will stay encrypted. So whenever service A receives the request from service B, service A will deliver it back to Dapr, and then service B will receive the result or the output of service that you want to call back from the Dapr sidecar. So it's a very intelligent system of sidecars. And that's pretty much it for the service invocation building block. By the way, for those of you who are listening to us, don't hesitate to ask any questions right now. It doesn't matter actually with where you are watching this, because as far as I know, Mikhail can see all the questions that are coming. So at the end of this talk,
overlay.
okay. At the end of this talk, we will answer all those questions. So that's pretty much it for the service invocation building block. The idea of it, once again, is to be able to locate where your services are running and to call them. And in the earlier version of Dapr, it used to feature some strategies like for handling some intermittent issues. Like if you call a service that at that time that you call it isn't available, Dapr tried to do a backoff retry with some configurable periods. But at that point, I'm actually not sure what happened with this retry functionality. I think it's still in there, but I haven't checked in a while. So the other thing that you can do with Dapr is to manage state. You can persist state and you can gather it after that. So just to mention some of the systems that or the state stores that Dapr supports, those are, for example, Couchbase, Memcached, MongoDB, Redis, of course. You can use also relational databases like PostgreSQL and MySQL for storing state. And in order to configure such building blocks like the state management building block, first of all, you have to configure the component that is staying behind this building block. So basically, this component is the thing that configures the behavior of your building block. In this component, for example, if you are targeting Redis, you have to provide basically where the address where Redis runs, and also the username, the credentials that you can use to connect to this state store. So the state store is very simple. You once again call the sidecar API of Dapr, and it provides the operations for you that you can execute with the state stores. The good thing about that is that you don't have to change anything implementation-wise whenever you decide to switch over to a new state store. So in other words, if you decide to move from Redis to, let's say, PostgreSQL, you just have to reconfigure this component. And that's it. You just have to restart Dapr and everything will be working. So the next building block is actually publish and subscribe. Maybe this programming pattern is familiar to you whenever you use some message brokers like, for example, Service Bus within Azure. But the publish and subscribe building block allows you to publish to interface with, let's say that they are messaging systems, because some of them are more like messaging, fully featured messaging brokers, while others are just message queues. But the point of this building block is to be able to publish messages within some topic in this messaging system, and then subscribe to them. Actually, all your apps can subscribe to different topics. And once again, you do all those operations via the Dapr API. So this this webcast is, by the way, rather unusual, because I have to talk you through some difficult concepts within any slides, but we will try it. So Dapr stays in between the communication with your applications and the message broker. So on one side, you can have applications that are publishers, and on the other side, you have applications that are identified as subscribers. And the way to publish a message to a message broker is to basically call the Dapr API or the respective endpoint of it. And the way to subscribe to incoming messages is to basically either use the declarative approach or by using the programming approach for doing that. So what I mean is that for the programming subscription approach is where you are exposing an endpoint of your API, where Dapr knows that it can find all the information regarding what topics you are interested in listening to. Whereas the declarative approach for setting up the subscriptions is via basically the component. So you configure it in YAML, in the plain old YAML, which many folks don't really like, by the way. Sometimes it's just confusing. Another building block is the bindings building block. So if you look at it, it may look like it has to do something with publish and subscribe, because it also integrates with things like Kafka, MQTT, RabbitMQ, or Redis, but it's not the case. I see bindings as the integration building block of Dapr, where you can interface with external systems. So basically, they can call your apps, and for calling your apps, they will go through the Dapr runtime. And in the end, you will just expose an endpoint within your application that Dapr will call depending on what happens, on what events are happening, and what you have configured to basically listen on. So the binding components is divided into two parts. The first part is the input binding, where external apps can call inside your platform and invoke some methods of your application. But the other part is output bindings, where you can just execute some commands on external systems. Like, for example, you can publish, you can send an SMS message via Twilio, or you can send an email via SendGrid by using those output bindings. Or you can, for example, post to Twitter, which is very exciting. The other building blocks is the actors building block. You may be familiar with this programming model, where at the center of it you have the actors, which are basically the lowest level of computation, and basically you can model things with actors. Or I by the way see actors as object-oriented programming, but on steroids, because you can mix and match object-oriented programming with the cloud, and you can achieve spectacular things. So Dapr features such kind of building block, which implements the virtual actor pattern. So the virtual actor is basically one of the differences, that the lifetime of those actor objects is indefinite. So basically, they are not tied to their in-memory representations. They just exist somewhere, but you don't care where they exist. You don't care how they are scaled out throughout your cluster, your Kubernetes cluster, because Dapr takes care of this. And basically, you can model real objects from the real world, something like digital twins. I know Michał is very excited about that. But Dapr handles a lot of those things that make it easy to use actors within Dapr, like reshuffling the actors within your Kubernetes nodes, managing the placements. So Dapr has to decide whether to place your actor instances within your Kubernetes cluster, and how to do things like distribution and failover, because Kubernetes nodes do die, actually, do go down. And it also manages the concurrency between those actors. And essentially, for those of you who have used Service Fabric, basically Dapr, the initial implementation of Dapr, or the initial interface that it used, was 100% the interface of Service Fabric, the reliable actors within it. And another building block is when it comes to managing secrets. So as opposed to identifying what library to use to interface to Key Vault, for example, when you want to retrieve some secret, you can use the Dapr secrets management building block. And at some point you can decide to choose from, for example, Azure Key Vault to Kubernetes secrets or to HashiCorp Vault. And you can do this just by reconfiguring the component that is controlling how this building block behaves. So what is the idea behind this secrets management block? The idea is to be able to read secrets from your secret store of choice. It's very simple, and Dapr takes care of the communication with your secret store of choice. So that's pretty much it. It's really simple. And the other thing that you are taking for granted is distributed tracing. So Dapr, because it stays in between the communication with all your apps, and it has this intelligent system of sidecars, it is able to see how the traffic is flowing within your cluster. So basically, if an application calls application A calls service B, then service B calls service C, Dapr is able to rebuild this chain of invocations because it stays in between all those calls. And then you can see a graphical representation of the communication between your services in things like Zipkin or in, for example, application insights, the application map that it provides. It depends on how you collect those logs, because you can configure the collector to behave in different ways. But after that, you can basically reach each and every distributed tracing system, like you can ingest in Datadog, Instana, Jaeger, or things like that. And last but not least, there is a new building block coming to Dapr in some of the next releases. It's for configuration management. So think about it whenever you want to use some kind of a configuration that's centralized, like Azure App Configuration or AWS configuration that can span environments, it can span applications. You once again have to identify some API or some library that you can use to interface to this configuration service of choice. And this new building block will simplify those things for you, actually. So those were the building blocks. I realized it was a very quick introduction and go through all of them. And we oversimplified a lot of the things here, but I hope you you gain some knowledge about what Dapr is and what are the building blocks.
I have one question here. Do you think that Dapr as platform which provides such kind of abstraction layer and makes actually systems agnostic to specific technology and some third-party services is easy to learn? I mean, what is, regarding to your experience, learning curve for regular developers?
Okay. So Dapr itself is easy to learn, I would say, because it features some well-defined APIs. I mean, just by reading the documentation, you can see what a given building block supports and what are the operations that you can or the actions that you can perform via it. But the thing is that not all components within Dapr are created equal. Actually, a good number of them are contributed by the community. And it depends on basically across those components on how they have been implemented. Because, for example, Dapr has to take the kind of the common how do you say that the common divisor problem. So you basically package functionality that is generic for all systems, but you know that if we compare, for example, message brokers, they differ if you compare them with each other. And there are different things supported within all those systems. And here comes the problem with the components, because some of the components are implementing features that others don't. So, for example, if we talk about the state management building block, some of the components do support the time to leave, the time to live, which makes your messages expire. But this actually depends on the end system that you are going to use and to target this component to. So maybe the difficult thing is to basically to know all those systems, although this is not required at all. But if you want to change, let's say from reusing the example from Redis to PostgreSQL, you have to know what is supported within those components and whether they fully support all the features that Dapr provides, or they are just staying at the minimum. So maybe this is the most difficult thing. Yeah, I cannot think of something else actually.
And what about the tooling which we can use to start develop applications with Dapr?
So Dapr provides several SDKs that you can use. Those SDKs are, for example, for .NET, for Java. They have a Go SDK, they have a PHP, and a couple of others. And those SDKs, you can integrate them within your application. If you want to use something that is very easy to use, as opposed to calling and making API requests to the Dapr API, you can reuse this functionality that's coming from the SDKs. It's coming out of the box. You just install it. I mean, if you are not a fan of composing HTTP requests, you should go for it. But of course, there is no requirement for using the SDK. You can go with plain HTTP calls or plain gRPC calls, because Dapr also works with gRPC, and you can also execute those operations via its gRPC API. So Dapr, after all, is a binary when you're developing on your local machine, and they provide a COI in order to start this sidecar that I talked about, and also to start the application itself. You can use this COI to start the application, but sometimes when you have a lot of applications, it becomes kind of difficult to start them all. And here we have the Visual Studio Code extension that makes the work with Dapr easier locally, because you can see all the Dapr applications that have been started on your machine. And you can also invoke operations on the Dapr API right within this Visual Studio Code extension. So it makes things easier for you. And if you are having a giant microservices application within Kubernetes, and you don't want to basically host the entire Kubernetes cluster with all the containers within it. If you don't want to host this within your laptop or within your machine, you can use this Bridge to Kubernetes extension. Basically, in earlier versions of Dapr, the Bridge to Kubernetes extension didn't work very well. But in the latest versions, they have improved this support. So now you can just run one container of your application. You are developing it locally, and for the other part of your microservice application, you are interfacing with a real Kubernetes cluster running, let's say, within the cloud. So in this case, you can just replace one small microservice. You can work with it locally. You can debug it. But for calls that are targeting different other applications, it is going back to the cloud. And there is one other new thing here, that is Dapr Sidekick. And this is for the use case where you host Dapr yourself. You don't rely upon having Kubernetes doing it for you. Dapr Sidekick allows you to integrate the Dapr, the start of the process, within your web application. So your application, by using Dapr Sidekick, can start the Dapr sidecar process, and you don't have to do anything else than that. Because otherwise, if you don't use Dapr Sidekick, you have to figure out a way to start your Dapr processes whenever you start the Dapr application, and you have to deal with problems. So from times to time, the process can go down. You have to manage it. But if you choose to use Dapr Sidekick, you can basically take out this responsibility. Other thing is using Dapr with and integrating it with other commonly known services like Azure Functions and Azure Logic Apps. So you can integrate Dapr within your serverless applications. But there is a small caveat here, and it is that Dapr works with those technologies, but with their self-hosted versions. So you have to self-host Azure Functions, its runtime, and you have to self-host Logic Apps in order to be able to use Dapr with them. And another thing is to use Azure API management with Dapr. And once again, you have to use the self-hosted gateway.
By the way, do you have any insights if it works in the same way with serverless components for other platforms, excluding Azure?
No, not really. Currently, the integrations that I know of are kind of related to Azure. So I don't really know anything about, let's say, Lambda integrating with Dapr. But if it's able to access your Dapr APIs and to access the place where Dapr is running, there shouldn't be any problem for using Dapr with any other serverless platforms.
Yeah, it is reasonable. And we discussed also with you that one of the big advantages to use Dapr is when we have legacy applications. Can you share some insights about this?
Yeah, so kind of a common understanding within the microservices world, I think, is that you have to redesign everything by using the latest technology to make it work within Kubernetes, to use the latest CNCF projects, and to be innovative. But there are a lot of cases where big enterprises just cannot afford to move that fast to the modern technologies. So you have to find a way to mix and match between both, or rather have a combined experience. And that is also one of the use cases where you can leverage Dapr. As I briefly touched on this during the beginning of the talk, for name resolution, you can use the console component, and basically console can locate your microservices no matter where they are running. So, for example, if you are running on Windows, you can host it within. Sorry. If you're running on Windows, you can host it on a virtual, but at the same time, you can have a Kubernetes cluster running somewhere, and at the same time you can have a Linux machine, and you can consolidate them all within your within a single environment by using this console name resolution component. You don't have to redesign everything and start from scratch. I guess that's the current idea.
Great. Yes, it is very useful, I think. And at the end, what you can say for all software engineers who consider to start work with Dapr, something like recommendation. There was an issue with connection with you, Rado. I'm not sure if you heard the last question. We cannot hear you.
Hello, can you hear me?
Yes.
Well, I'm facing some connection issues, and that's why I stopped my camera because I guess the camera takes the priority over the microphone. So my top one advice for all software developers who are willing to try Dapr is to basically explore the GitHub repository, to learn how Dapr is working, and you can absolutely do it with by just looking through the GitHub on the docs, and you can also engage with the community on the community channels, of course, because a lot of the community members are very helpful, and if you face some issues, you can always ask them. The community is thriving.
Yeah, it is very good recommendation. So thank you very much for this webcast. I think that it was very interesting and you have very, very good and interesting experience with Dapr. Hope that we will be able soon to have a next part related to this platform where you will be able to share some new things.
Thank you, Misho, for having me. And maybe here is the time for having a shameless plug for the event that we are having on Wednesday, because we haven't seen each other for quite a while, I guess more than a year because of this whole COVID thing. So maybe you can at last share the details of this Wednesday event.
Yes, we have on Wednesday evening BRGS Summit event in central part of Sofia, Maimunarnica. Many of you know this place. So we are expecting you there with many small light talking and a lot of other attractions. And 10 days later, on 28th of August, we have also Data Saturday in Plovdiv. It is in the same time when Kapana Fest is organized. So all of you are welcome. We will have really nice event. Thank you and hope to see you soon.
Thank you.